Okay, this is day 4. Okay, this is day 4 homework for AP Stats. Just a quick word before we start. If classes cancel tomorrow, so if schools cancel tomorrow on Wednesday, we will. I will put the lesson online. It's basically just a review, so that's what we're doing. But I'll review and I'll go through the questions, and you'll still have the same homework questions, and I'll post all that. So on Thursday, you'll be turning in tonight's and tomorrow. That's if we don't have school. Okay, so which I'm assuming it's going to be the case. Alright, first question is number 28, the density of the Earth. In 1798, the English scientist Henry Cavendish measured the density of the Earth by careful work with a torsion balance. The variable recorded was the density of the Earth as a multiple of the density of water. Here are Cavendish's 29 measurements, and all that we want you to do in number 28, you've already done that, or that problem was prior to this set of problems, but all I want you to do is get the mean and get the standard deviation. And you don't want to do that by hand, so do it from the calculator in list 1. Get the mean and the standard deviation. There's too many numbers to do that by hand, so just do it that way. Alright, and we move on to number 40. Question 40, for both classes, we did that in class. It talks about the phosphate levels, and there's 6 numbers, and you're finding the mean and the standard deviation by hand. You will have to do that on the test also by hand. Number 41 is talking about Roger Maris's home runs. Second period we did that in class also. First period did not. But Roger Maris, there's 10 home runs. It gives you the mean. It wants you to find the standard deviation, so you use the steps. Remember, to get the mean, we added them all up and divided by 10. To get the deviation, you subtract, you do the observation minus the mean for each of them. You then square that to continue on. You then add up all the squared numbers, divide by n minus 1, which would be 9 in this case, and then take the square root, and that gives you the standard deviation. So there's like 5 steps there. After you do that, you want to take out the outlier. So the outlier would be the year he had 61 home runs. And then, once you take out the outlier, it wants you to calculate... it wants you to do X bar and S in the calculator. So with those 9 numbers that are left, find the mean and standard deviation in the calculator. Compare that to the mean and standard deviation when there were 10 different ones. When you take out the outlier, what did that do to the mean and standard deviation? And you need to talk about what that did. Alright, the next problem is 43. 43. I missed it here. 43 says, this is a standard deviation contest. I kind of talked about this for a minute. Choose 4 numbers from the number 0 to 10, and you can repeat. What would have the smallest possible standard deviation? So think. Standard deviation is how far something goes away from the mean. So what 4 numbers could you pick that would have the smallest standard deviation? And you can repeat. So that's a hint there. Then choose 4 numbers that have the largest possible standard deviation. Well, your hint there is if you want it to be the largest possible standard deviation, then you want to pick the farthest away that you can from each other. And then C, is more than one choice possible for A or B? Explain why you might have more than one choice for A and then maybe for B. Again, you can kind of use the back of the book to help you in some of these to go through this. Okay, problem 44. As I flip a couple pages. 44 talks about cockroaches. Find the mean and standard deviation in part A by hand. Okay, there's only 5 of them, so that shouldn't be tough. In part B, it says she's accidentally measured it in inches rather than centimeters. There's 2.54 centimeters in an inch. So you need to take all of those numbers and multiply by 2.54. And then what is the mean and standard deviation of those numbers? So you're going to do mean and standard deviation by hand again, but take all those numbers, multiply them by 2.54, and then use those to get the mean and standard deviation. And then at the end it says, what would you estimate as the average length of the population of cockroaches? So again, it's a small sample. We only have 5 of them, but if our mean and standard deviation are good, then what does that say? So the lower your standard deviation, the more confident you would be in your answer of that. Okay, we move on to 47. 47 says, get your hot dogs here. And this talks about these hot dogs, and it really breaks them down into beef hot dogs, and then it breaks it down into meat hot dogs, and then poultry hot dogs. And then it talks about the calories and sodium for each. And what you're going to do is some box plots. The box plots, now I need to really help you out here. We're going to basically, there's going to be 3 box plots, okay? So there's going to be, well actually, there'll be more than 3 at the end. But there's going to be a total, it says side-by-side box plots. There's going to be a total of 6 box plots, okay? So what you want to do is you want to make 3 box plots you want to look at the calories in beef, that's 1 box plot. The calories in meat, that's a box plot. And then the calories in poultry, that's a box plot. Okay, and you want to put all 3 of those together, like side by side, one on top of the other, so you can compare them. Okay, so that's 1 set of box plots. Now, for each one, you're going to have to do a 5-number summary. The minimum, Q1, the median, Q3, and the max. So, for instance, the beef hot dogs, you would do the calories starting at 186 and going all the way down to 132, and you would make a box plot for those. For meat hot dogs, you would do the calories from 173 to 138. You would get the 5-number summary of that, and you would make a box plot of it. For poultry, you do the calories starting at 129 all the way to 144, and you'd make a box plot of that, okay, with a 5-number summary. So you'll have done 3 5-number summaries and 3 box plots for calories. Then we go to sodium, and you're going to do a beef hot dogs box plot with sodium starting at 495 and going to 253, another 5-number summary for it. You're going to do a meat box plot for sodium starting at 458 to 339, a 5-number summary for it. And then you're going to do a poultry box plot start with sodium starting at 430 to 545 and do a 5-number summary with it. So at the end of the day, you'll have 6 different box plots, 3 for calories, 3 for sodium, and you'll be able to compare beef, meat, and poultry in how can you compare them based on calories, and then beef, meat, and poultry, how can you compare them based on sodium. And you need to write a few sentences about it because that's a lot of information from that. So 47 will take a little bit of time, but it's not very difficult. Okay, 48. Which AP exam is easier, calculus or statistics? It tells you how many people made 5s, 4s, 3s, 2s, and 1s. And remember, 5 is the best score. Make a graphical display, it says, to compare the AP exam grades in calculus and in statistics. The graphical display that I would make is a bar graph, but you want to do what's called basically a double bar graph, which means on the bottom, your x-axis should be your grade on the AP exam 1, 2, 3, 4, and 5. And then the y-axis should be the percent of students that earned that specific grade. But what I mean by a double bar graph is for the 1, like for say the grade of a 1, you would say calculus, and that would be at 16.8%, so you would make that bar. But then directly beside that bar, you would do statistics in maybe a different color or shaded in, and it would be 25.8%. So for a score of 1, you're going to show both on the same bar graph. Then you move over and do a score of 2 and show both of them, calculus and statistics. Then you go over to 3 and show calculus and statistics. Then you go over to 4. Again, make sure you're labeling your graphs. Make sure you labeled your box plots. They all got to be labeled. Okay. And then you're going to just explain based on the bar graph which one you think's easier, the calculus or the statistics. All right. Moving on, question 50. Basketball playoff scores. A back-to-back stem plot on this. All the Division 1 AAA, all those are going to go on the left side of a stem plot, and all the scores for VAA are going to go on the right side of the stem plot. So your stems, as you go down, are just going to be, what's the lowest score in all the games? 30 something. So 3, 4, 5, 6, 7, 8, 9, and 10 will be your stems. Your scores for VAA will be on one side. Your scores for the AAA will be on the other side. Okay. Then part B says describe the shape, center, and spread. So you look at the stem plots, each one, and describe what the center is, what the spread is, what the shape of it is. And then the last part says, is there a difference in margin of victory? So look at how much each team won by. For instance, 71 to 38, that's a 33-point margin of victory. The team won by 33. 52 to 47, that's a 5-point margin of victory. Do each one, see how much they won by, and is there a difference from 1 AAA and VAA? Is there a difference in the margin of victory?